Good morning. Glad you're all here. Glad you're interested in dyslexia. I have a lot of stuff to present today, so I'm going to be rattling on pretty quickly. But if you have questions, please feel free to jot them down or just blurt them out, because generally speaking, if you don't, you forget. So I'm certainly okay with that. There's a printout for, kind of following up what we're going to do today. This is just who I am. We don't need to worry about that right now. What do you know what dyslexia is? Obviously, dyslexia is a learning disability that's neurological in origin.
See why the previous people found that if she moves too much, which she probably would do.
It's going to be ready.
Yeah.
All right, I'll hold it like this. But one of the things that's really important is that we understand that it's neurological in origin. There's a genetic component to it, and it's neurology. It's not that kids are trying, they want to learn how to read, they're pretty excited to come to kindergarten to learn how to read. That's not the issue. There's a lot of bogus information out there regarding dyslexia, but I'm a research scientist, so what I tell you is based on science. So it's important to understand that it's neurological in origin. These difficulties generally refer to the phonological component of language. We really look at dyslexia as a special case of a language disability at this point in time. My own research in the early 90s indicated that they actually have difficulties discriminating with speech sounds. So if you cannot discriminate between speech sounds, there's a whole lot of other things that require that to occur before there's going to be some understanding of how to read. Secondary issues include reading comprehension, which is the goal of reading, and also the growth of vocabulary, because we learn a lot about our vocabulary, we learn a lot about infrequent words by reading. Because if you think you're going to learn about infrequent words by listening to the radio, watching television or cable, not going to happen. So, characteristics of dyslexia. Hopefully you've seen some of these things. Obviously, difficulties with accurate or fluent word recognition. Look at words that many times kids who have dyslexia will try to decode the first part of a word and then guess the rest of it. So you see those kind of things. Poor spelling and decoding issues. Spelling is a major issue. Spelling is a more difficult task in a sense, because if you look at cognitive science, there is recognition memory, like when you took a multiple choice, or as us professors like to call them multiple guess tests, right? Those are generally a little easier because you can recognize the answer. But if on an essay exam, you have to recall all of that yourself. And essentially what spelling is a recall task. Plus, in our next session, if you're going to be around for that, we'll see how the English language really messes people up. And particularly the writing system. Because the writing system is very difficult. It's a very opaque writing system. There's 43 phonemes in English language, roughly. How many letters are there in the alphabet? 26. How many vowel letters are there in the alphabet? 5, 6 if you count Y. There's 19 different vowel sounds. So it's almost like someone a few hundred years ago thought, what writing system could we come up with to make sure no one knows how to read? So if you're a good reader, it's miraculous. I mean, there's Finnish researchers who say, I don't know how any of you guys ever learn how to read in English. But if you have dyslexia, which is a situation where neurologically speaking, things aren't really wired to learn how to read very easily, and then you throw them into a very opaque writing system like the English writing system, it's really a difficult scenario. We know that results from a deficit in the phonological component of language that's unexpected and related to other cognitive abilities. We're not going to talk about discrepancy models. Discrepancy models are of the past. They're inappropriate. We should not be using them at all anymore. And places that do are behind the times. Definitely, there's no doubt about that. But what we mean by that is the individual certainly has capabilities of learning all kinds of stuff, but the neurological system just does not allow them to connect up the visual to the sound and all those types of things. One of them that I have a little bit of disagreement with is that the notion that dyslexia even occurs with effective classroom instruction. I don't really believe that, because if we actually had the appropriate classroom instruction for the kid with dyslexia, they'd learn how to read. In fact, many years ago, I told one of the school systems I was working with that I wanted to write a kindergarten reading curriculum to prevent kids from having actually reading failure as a function of dyslexia. And I was just musing with this individual because she was really fun to talk to, and then every time I saw her after, I said, "Did you write it yet? Did you write it yet?" So eventually I did. And it's out there, and the school, it's been out there for about 8, 9 years, and the schools that use it, it's working effectively. We roughly have 20% of kids who have dyslexia and a greater percentage that have reading failure, right, 33%, something like that. And we dropped that 20% to 33% down to 5. So it's called Secret Codes. You won't find much about it out there because it's my curriculum, and my wife and I wanted to actually essentially give it to school systems to use and not really sell it. And so that's what we're attempting to do right now. School systems that are interested, they pay for the cost of it, and that's it. There's no other stuff on top of that. My wife and I start off poor, and we're not poor now, so we don't care. But secondary problems include comprehension. Obviously, that's the goal of learning how to read. And obviously, if you have reduced reading experience, then you're going to have problems with vocabulary development and with background knowledge. Because essentially, we say this in the school system, in kindergarten and first grade, you learn to read, and then in third grade and beyond, you read to learn. But what we're actually finding out, even with good readers are still learning how to read in 5th grade. So there's a lot more going on with reading than we used to think there was. It affects, roughly dyslexia affects 15 to 20% of our nation's kids. Half of them do not graduate from high school. And it's interesting, but you know that compensatory education stops at 16. Like if you want to drop out at 16, no one's going to come to your house and drag you to school, right, in most states. So when we look at graduation rates across the country, they're usually inflated tremendously. You'll see 95 to 98% graduation rate. Not happening. There are risks for parental abuse, which is quite unfortunate. In fact, some researchers in Canada looked at 13,000 cases of young adults, and they found that roughly 7% of kids who did not have dyslexia were abused physically by their parents, which is too much. There's no doubt about that. Well, you want to guess what it was for dyslexic kids? 35%. 1 out of 3 kids were physically abused by their parents because their parents have no clue what dyslexia is about. They think, well, you're smart, you know everything there is to know about the Thunder, the statistics, or baseball teams, or Oklahoma State or OU, whatever the case may be, and they're like, then how come you're not learning how to read? Well, I know what it is, you're lazy, we're going to fix that. That's not the problem. In fact, one of the things that we brought here at our table is I have dyslexia children's books, and we wrote them for kids to understand what it is to have dyslexia, what it is about. It's neurological, there's genetic components to it, those types of things. We also wrote it so that parents would be reading it to their kids would learn about dyslexia. So, if you want to grab one of these too, but we're selling one of those tables, and all the profits go to our nonprofit, which is to help kids become competent readers. But anyway, they're more likely to have self-esteem issues. We usually talk in education too much about self-esteem. For example, we used to think that bullying was just a problem of self-esteem. We actually started doing some science and found out, a lot of bullies actually have pretty good self-esteem. But what I mean by that is the notion of it, kind of paraphrasing Henry Ford, if you think you can or you think you can't, you're probably right. These kids give up. And first graders, they see all their friends learning how to read, and they're not doing so well, and they think, well, I'm just what? Stupid. Yeah, so or dumb or whatever. But if you think you're stupid, then why try anything? And so that's where I'm talking about with the self-esteem stuff is really that notion. They're more likely to have depression and anxiety, particularly in high school. They're suicidal. We've had people, grandparents and parents say, "You've saved my granddaughter's life, you saved my son's life," because we do interventions, obviously. And I'm like, we're not curing cancer, thank you. But then you find out how many kids with dyslexia have depression and anxiety as a function of dyslexia and actually commit suicide. So in reality, if you can help kids become better readers, you actually are saving their lives to some extent. They're more likely to abuse substances, because generally people who abuse substances do so to escape from pain, psychological pain, emotional pain, physical pain. And so they're more likely to be involved with that. They're more likely to be in the juvenile court system, the criminal court system as adults and on public assistance. So we really view dyslexia as a social as well as an academic difficulty. Which, what we mean by that is, if we're able to help these individuals at a younger age become competent readers, not necessarily quick readers, but competent readers, then they're going to have a whole life ahead of them that's going to be completely different than if we didn't. Now those are the negative things about dyslexia. And obviously there are. Those people out there who say dyslexia is a gift and all that kind of stuff, hogwash. Ask any kid who has dyslexia, is it a gift? Do you like that? If it's a gift, I trade it for something else. It's not a gift. It's a difficulty. In our society today, we require that everyone is able to read and read fairly well. We have national initiatives of having people reading successful by 3rd grade. If it was such a gift, why would we care? Because it's not a gift. Now, do they have other skills and abilities that are wonderful? Absolutely, just like people who do not have dyslexia. But in itself, I don't think there are going to be too many kids out there suffering in classrooms, hoping their teacher doesn't call on them to read, saying, "Yeah, highlight my gift, please, do so right now." Just don't think that's going to happen. But here are some individuals, we really won't talk about them too much, but these are individuals who have been very successful and have had dyslexia. There's lots and lots. People are coming out, it seems like every week, saying, "I have dyslexia and I'm still doing well." And that's good to know for these individuals that, I have to say something about Dr. Helen Tausig though, because she helped found or co-found the field of pediatric cardiology. And she did so, she got her MD in the 1920s, which a lot of women really weren't involved in medicine at that point in time. And she had dyslexia on top of that. And early in her career, she lost her hearing. And so in cardiology, you usually have to listen to the heartbeat, right? And she's an amazing woman. She's actually an amazing individual. Instead of using a stethoscope, she'd use her fingers and put the fingers on the kid's chest, and she could feel the heart rate and could tell what was going on. So, and these other individuals, Jack Horner I like quite a bit too. He's severely dyslexic, had some serious issues with his father. And he did not get along. His father beat him. And if you ever want to really hear some pretty sad stuff, look at Jack Horner on YouTube, where he talks about dyslexia and his father. It's just heartbreaking. But here he is. He can't hardly read at all. The most famous paleontologist on the planet. He not only worked with Jurassic Park on the movies, but he was the one that discovered that dinosaurs actually took care of their young. And although we've had dinosaur bones since the 1880s, he's the first one to say, I wonder what would happen if we cracked into that egg. And he did. They found embryos. They found dinosaur embryos. Obviously a pretty remarkable individual. Some common myths about dyslexia. It affects more boys than girls. Generally speaking, we talk about developmental disorders, psychological disorders, any kind of disorder you want to talk about. Males have it more frequently than females do, usually 3 to 4 times more so than females. Not so with dyslexia. It's roughly 51% boys to 49% girls, so it's really not that much of a difference. It's not a visual difficulty. Letter reversing is a common thing that kids do when they learn how to read because some letters look the same. B, D, P, Q, there's a bunch of them, and they're very confusing when you're first to learning them. Even as an adult, you might think, is that a D or a B? David, oh, it's the D, it's like the one at the end of my name. So, it is confusing. There's certainly no doubt about that. And the other thing involved with the letter reversing stuff is in kids with dyslexia, you're going to see it for a longer period of time. probably, even in high school, you see a lot of reversing and stuff because they haven't really gotten down the code yet. And until you get the code down, then you're going to have some difficulties with letter reversing. That's common. It's just you see it longer with kids with dyslexia because it takes them longer to figure out the code. Individuals who are intelligent do not have dyslexia. Well, say that to some of those guys in the previous page. Obviously not true. People with dyslexia cannot read. We teach kids every single day how to read who have dyslexia. In fact, we've worked with individuals as old as 63 to learn how to read who had dyslexia. Dyslexia will be outgrown. It will not. If you don't do anything, if you don't do some type of explicit instruction in first grade and say, well, we'll just keep, pass them along, and, or we're going to keep them in first grade until they learn how to read, they'll be 21, or actually 16 and leave. Actually, they'll be gone long before then. If individuals with dyslexia would just try harder, they would not have dyslexia. It's not true. And my favorite really is Einstein had dyslexia. He did not. He did not have dyslexia. In fact, the best biography that was done on Einstein, huge, thick tome, never mentions once anything about dyslexia or reading difficulties. The early letters between his mother and other individuals said that Einstein was at the top of his class. Would not have been if he had dyslexia. A lot of times people also will say that Leonardo da Vinci had dyslexia because he wrote backwards. He did that on purpose because he didn't want people to read his notes, but he could write forward. And in fact, as we'll find out in the next session, that Leonardo, what language did he speak and read in? Italian. One of the easier writing systems out there. So even if he would have had dyslexia, no one would have known, because he would have been able to read pretty well. And who would have known anyway, because we didn't educate the masses back then. So, I have a problem with individuals saying that Einstein and Leonardo da Vinci had dyslexia because it reduces credibility because they didn't. We need to speak the truth based on what science is. I put this up here so you can see that if you look at the beginning of first grade, the differences between good readers and poor readers, or good readers and people with dyslexia, is pretty small because they're not reading all that well. But each year that gap gets bigger and bigger and bigger, and there's millions of words that kids with dyslexia have not read by the time they've got even to fifth or sixth grade. So that gap's pretty important, and it's very frustrating for them to see themselves being left in the dust. I want to talk just a teeny bit about attention deficit hyperactivity disorder, which you might think would be a strange thing to talk about with dyslexia, but it's not. Because 30 to 50% of kids who have dyslexia, and adults actually, also have ADHD. So we're interested in ADHD primarily because it impedes progress of the student, interferes with class dynamics, right? Okay. I don't know if I was just making that part up. Just kidding. There's difficulties with retention and graduation rates, reading difficulties, and dyslexia are masked by ADHD. Because at our center, we do full evaluation of kids, and parents will come in and say, we just want the dyslexia part, we don't care about the ADHD part. We say, if you come here, you have to get both. Because people will come in, and behaviorally, if you look at a child's behavior, sometimes it looks like they have dyslexia where they actually have ADHD primarily in attentive presentation. Or a parent will come in and say, we just want them assessed on ADHD, and we do the assessment. They don't have ADHD, but they have dyslexia. Because the behaviors of a young child in a classroom who cannot do what you're asking to do is going to look a lot like ADHD. So it's important to really drill down to the bottom of that. And it's surprising how we can be fooled by that. So really we need a bona fide assessment of both to really figure out what's going on. So we see sometimes kids who just have dyslexia. Sometimes we see kids who have ADHD. Most of our kids that we see have a little bit of both. And occasionally we'll see a kid who has neither. And they come in and there's issues that are going on. There's a 15-year-old that we assessed probably 10 years ago. We found out he didn't have dyslexia, didn't have ADHD, and we interviewed the child as a function of the process. And he said, well, I don't have any problems reading, I don't have any problems at school. I'm really mad at my mom, so I'm not doing anything. Okay. Then we suggested they go to family counseling. because academically things are okay. But if you don't look, so you don't know. And you can't really intervene properly if you don't know what the diagnosis is. You wouldn't want to go to a doctor that says, well, here, take these purple pills. What's the diagnosis? I don't know, but let's try this. Well, that's ridiculous, right? We absolutely need to have a diagnosis first, or at least have some type of evaluation of what's going on before we can really do a very decent job of intervening. So ADHD is masked by reading difficulties, etc. They appear similar. So it's really important to get those separated out and figure out which is which. So we assess for ADHD because, what I just said, 30 to 50% of kids have both. It's comorbidity. And obviously anyone who has ADHD is going to have some difficulty learning how to read because it takes an attentional capacity, right? Even some researchers are saying today, which I find almost humorous, they say, part of the reading process, there's an attentional component with reading that is different than the attentional component overall. I'm like, no kid. You think a kid's learning how to read, it's an arduous task. It takes some effort. Genetic components of dyslexia. When we look at the relative influence of genetics, and you can see in this box here, all the way to the far left, we have, as an example, phenylketonuria, PKU, which is a genetic issue. Interestingly enough, with PKU, the ability to process phenylalanine is not there. You don't have phenylalanine hydroxylase, and so it builds up to a toxic level that can cause brain damage. It's toxic. But even phenylalanine, PKU, which is genetically an issue, is not 100%. There's some environmental impact. Not a lot, it's mostly genetic. And sometimes people think, well, that doesn't make any sense. Because we don't understand all there is to know about genetics. Because genetics is extremely complicated. You can have 3 kids that look exactly the same, and the 4th one looks differently. Oh, I knew it was the man. No, it's just the way genetics plays out. Interestingly, with PKU, even though it's a genetically based difficulty, environmental interventions help us not to have particular problems, right? So, and then on the other end, we have post-traumatic stress disorder, which is an environmental. If you're not exposed to a traumatic event, you're not going to have PSD, right? So you're not going to have that. However, even having said that, your personality and how you're built genetically is going to dictate to some extent how you interact with the environment and how much, like some kids, we call resilient children, they deal with all kinds of horrible things, it doesn't affect them. And some kids, even little things affects them. So genetically, your coping strategies actually play a pretty big role. Well, dyslexia has about a 70% heritability, so there is genetics components to that. The environment plays a role too. And even if you look at identical twins, what you'll find is they share how much of their genetics in common, identical twins? 100%, right? They come from the same zygote, monozygote, same zygote, 100%. But the uterine environment changes them. So when they're born, they have different fingerprints. How could they? The environment has already changed them, right? So even, I'm a developmental psychologist, and we've probably not given as much credence to interuterine life than we should have. Now, some of the things we thought were genetically based, everything's genetically based, obviously, but the uterine environment actually has a huge impact. And then, of course, when a person is born, even larger impact that happens after that. So here's some genes that are related to dyslexia. You don't really need to know those, but there's a number of researchers that look into each of those. My favorite is the DCDC2 gene. It plays a really important role in the development of dyslexia. The DCDC2 contains single nucleotide polymorphisms, or SNPs for short, and it seems to play a role with dyslexia. In this particular SNP tells neurons in prenatal life where they're supposed to go in the brain. And you can see on the left, there's little kind of canals or valleys, and then on the right, they're being transported, the neurons are being transported. Those are how our neural circuits are being created. Now what's also interesting is our neural circuits are changed and modified synapses are modified throughout our life. If you learn anything new today, as a function that we're talking about, you've changed neurochemistry, because that's how what our memory is neurochemistry, neural circuits. But what happens here with the DC-DC2 gene is that with individuals, as the hypothesis goes, is that the neural circuits are actually not being laid down. So on the left, what happens here, this occurred in a study with mice. What they did was they didn't mess with the DC-DC2 gene at all. And you can see that it's kind of not, it's a little blurred, but there's actually pathways there. You can see nice pathways. On the right side, however, they took that SNP out. And when they took the SNP out, what happened was those neurons didn't know where to go. So they just stayed there in a big lump, right? And so what the thought is with this DC-DC2 gene is that with individuals with dyslexia, it plays a role in not putting those neurons where they're supposed to go. Some neurological correlates. I like to put this slide up there. Don't pay a whole lot of attention to the right and left hemisphere stuff. We know cognitive science tells us that the brain is lateralized, which means that the right hemisphere does things a little bit better than the left hemisphere. For example, for most people, if you're right-handed, you have language. 97% of us have language. Broca's area is Wernicke's area. Our language processing is done as a left hemisphere. Our left hemisphere controls the right side of the body. The right hemisphere controls the left side of the body. And you can see that these are things that we found that are roughly lateralized in the right and left hemisphere. But that's as far as we can go. Because we start talking about left brain and right brain, we've gone beyond science. There's really no evidence to suggest there's right brain people versus left brain people and all that kind of stuff. It's, in fact, Sperry and Gazzaniga, who were the pioneers in looking at left and right brain stuff. I called Michael Gazzaniga a number of years ago and said, hey, what do you think about this right brain and left brain stuff? And you could tell he's like, oh, because I don't want to talk about this. And I said, well, here are my thoughts. And he goes, well, that's right. There's no science really to say that there's right-brainers or left-brainers, because in the middle of the two hemispheres, the corpus callosum, it's a major superhighway that they both connect to each other. And what goes on in the right specializes in some things, but it still communicates to the left what's going on. Only under certain, very rare circumstances is a person really right or left brain, and that's when, because of epilepsy, they've cut the corpus callosum so they cannot communicate. Then there's some issues. But other than that, like us, we have strengths and weaknesses, and the left and right hemisphere, probably some relation to that, but not enough to really talk much about it. In the initial reading process, obviously it's a visual process for those individuals who can see fairly well. You can see from the book to the eyeball. Many neurologists today kind of view the retina as part of the brain. So it goes to the retina. From there, you can see the long arrow that goes all the way back to the back of the brain. That's the occipital cortex, the visual cortex. And then from there, it starts setting it down, the letters, it's setting it down to a part of the brain that starts connecting sounds and letters together and looking at word form, where it starts setting it up. And then you can see it starts to go back up to the front. The front part is Broca's area, which we used to think was just related to speech production, but now we know that's involved in a lot of aspects of language. And so when we're looking at the initial reading process, where people are doing fMRI studies, and they're having a kid just read a particular word or looking at different words, this is the kind of stuff that we see. So if we look at kids without dyslexia, you can see on the left side, you can see that green area, which is simple temporal word association area. Then we look at the parietal temporal area, which word analysis, and then Broca's area. You can see that blue and green are pretty big, and there's a fairly, what we'd say kind of small red area. That's what we call brain activation. That's part of the brain that's actually working, processing this information. Individuals with dyslexia, you can see that the blue and the green aren't doing anything. So here we're connecting the genetics to actual brain processing. And the thought is that those neural pathways really didn't get laid down, and so they're not taking advantage of it in those particular areas, the back part of the brain. But this, I think, is really important. Look how big the red activation is. That's really important because the kid's doing everything in her or his power to read. And they're actually making part of the brain work really hard that isn't supposed to be doing that stuff. So when people say that if kids just worked a little bit harder, they'd be better readers, this is obviously something that tells us that is absolutely not true. Because they're even trying to get a part of the brain to do something it's not supposed to try and get to read. But the brain is really complicated. Some of this stuff, as a professor, I just want to put in there. You can read it later. We have a minimal amount of time today. But the brain is really complicated, and it does all kinds of things very rapidly. Reading is pretty amazing, but this is really what your brain looks like when you read. So if you're reading nonfiction, you're thinking about not only are you reading, which your reading is going from print to reading fairly quickly, right? It's an automated process. Things are going pretty rapidly. You're thinking about that. Well, you're also thinking about the character development, what he or she looks like. Oh my gosh, don't go into that house now. You shouldn't do that. You're doing all that kind of stuff, right? So it takes advantage of all of the brain. Another one of those myths that are out there is that we only use 10% of our brain. Not true. Absolutely not true, because evolutionarily speaking, if we use 10% of our brain, we'd have gotten rid of the 90% we don't use, right? That's just how that works. But it doesn't all work at the same time. It's instead of a parallel processing machine, it's serial processing. In other words, it flickers on and off very quickly between sites, which makes sense because it's a heavy user of glucose, so that if our entire brain was on the entire time, we'd probably starve to death. One of the reasons why we cook our food is because it is easier to digest and get the glucose to our brain. So we've done all kinds of things as human beings that's really kind of smart, and we've adapted pretty well. But when people tell you about the reading process, this is from the Human Connectome Project, and this is really what your brain looks like when you're reading, way more so. And that's why when you get to movies after you've read a book and you're like, that's not at all what I thought that person was going to look like based on the book, right? Because you're using all kinds of stuff. We used to think that the left hemisphere is more involved with reading, and probably is, but we're finding now when we track actually activation of axons, which carry information between synapses, we're finding it's actually going into the right hemisphere. So our whole brain is involved with the reading process. There's just really no doubt about that. There's some really good news though, and that is with remediation, we can actually change the way the brain works. And so you saw this before, but with remediation, these are individuals without dyslexia. And again, you can see the temporal parietal, occipital parietal areas are doing some stuff, and you see some stuff like the Broca's area. And you can see individuals with dyslexia, not really much going on in the posterior part of the brain. But after interventions, appropriate interventions, I should add, appropriate interventions, you actually see those areas activated again. So we can train individuals to train their brains to actually process this information, which actually makes sense. So this is kind of the introduction to what's going on with dyslexia. And I know we only had 45 minutes, so we kind of wanted to buzz through that, and that's why I separated into the kind of 4 different areas. So if you have questions at this point, let me know. And also, what time is it? Are we on time?
At 10:09, the clock. Right there on the board.
All right. So we actually have 5 minutes. That's amazing. Usually I have bad at it.
So the curriculum that you develop, how does that help remediate? How does that help train the brain differently?
Actually, in Dyslexia 104, we're going to be talking about that specifically, but if you don't come to that one, essentially, I alluded to the fact that there are opaque writing systems, which is what the English writing system is. And what I did is temporarily made a transparent writing system by using certain letters that always are going to mean the same thing to them initially. So what we do is we talk about codes and all those types of things. We tell them that we're going to learn a secret code. It's not really secret, but they don't know it yet, so it's kind of a secret. And they're going to be little detectives. As soon as you say that, they get all freaked out. Oh, little detectives, awesome. And the next day we come in, we talk about the fact they're learning the secret code, And then we show them the letter A and say, this represents A. And they say A. We show them some words with A in it. Not just initially, but medial as well. And then they write A, and they go A. And they do it only takes a few minutes the first day. The second day they would come in and review the letter A, which only represents A. We don't talk about letter names, because letter names actually are totally irrelevant to the reading process. You can never know a letter name and still be a great reader. Obviously it's good to know letter names, like how do you spell your name? Well, it's kind of good to know that. So we teach that at the end of the curriculum. In the very beginning we don't want to talk about it at all because it's still confusing.
So you're not saying A says A, B says but.
No.
You just show them and you say this is A.
Right, because it doesn't say anything in reality. It represents a sound.
Okay.
And then we review A, then the next, we review A, then we show them N. We say this is and then we do all that stuff, show them some words with N in it, and then they write N and they say because that's that kind of connecting it more to the brain where they're doing a couple things or multisensory stuff. Multisensory seems to be pretty important in this particular case. And then they review A also in the small group activity section. Then the next day that they come in, we review A and N and then show them T. And then they review A and N and we're at on T. The next day, the fifth day of the curriculum, which is a couple of weeks into the kindergarten school year because the first couple of weeks you're just telling kids where they're supposed to go. Here's where you go to the bathroom, don't do it in your chair, that kind of stuff. But the fifth day that they're doing the curriculum, review A, N, and T, then we show them the word and say, what does this letter stand for? We don't say represents. I don't like to say stand for because the prepositions end of the sentence. I don't like that, but little kids, okay, we'll let them do that. So what does this stand for? And they go, ah. What about this one? And they go, What about this one? And they go, let's put it together, and they get so excited, because what are they doing? They're reading, fifth day, they're doing the curriculum, and it's easy, because it makes sense to them. And so, if you can decode the word and, you can decode the word and at, and tat. I didn't used to use the example tat, because like, the kids don't know what tatting is, but someone said, tats, oh my gosh, yeah. Because kids know what tats are. So, tat. So you can decode the word tat. The next day they do S, and then they do D. And again, every time they do something new, they have to practice it every single day afterwards. So the curriculum in the beginning is like 5 minutes, in the end it's like 45 minutes. But by then the kindergartners actually can do this stuff. Because I was actually worried about that. Because when I first started writing it, I thought, this is what I want to do, and I started doing it, I'm like, I'm too stupid to do this, because that's what everybody says, and they don't think they can do it right. But my wife kept saying, well, ask your aunt, because my aunt's been a kindergarten teacher forever, and she said, I finally called her, and she said, yeah, that's a great idea, let's do this. And so we did that. But after they do S and D, then we want to connect that not only decoding is understanding the code, but to really understand the code, you have to be able to encode, in other words, write. And so we say, get your, they have letter cards out, and they say, we're going to spell the word ant. What does ant begin with? So they get their A and they put it there, and then they put their N, and actually they're spelling. They don't know the letter, they do know the letter names because their parents told them before they got to kindergarten. We're not talking about it. So just put them in order. And so they're getting that connection. Because when we were taught how to read and spell, we usually did reading in the morning because it's really excited, everybody's more awake, and then after lunch when the blood is diverted to our gut rather than the brain, we're doing spelling, which is a more difficult task, so we just don't get it. Spelling was arduous, but if you connect them early on, it's still going to be somewhat of an issue because spelling is a difficult task, and as we see after the next session, the English writing system really messes us up because there's so many different ways to spell homophonic words. It's crazy, right? So then we introduce, once they've read enough, decoded enough words, we keep adding on phonemes. Once they've read enough words, then we start building sentences. The sentences we initially do, there's no capitalization, no punctuation. Then we introduce capitalization. then we introduce punctuation, and then we ask them what the meaning is, and then we have spelling and a bunch, and they read sentences, and then when we've had enough sentences, we connect them together, do paragraphs. So by the end of kindergarten, most of the kids are able to read hundreds of words and decode words they haven't seen before. They're also able to understand capitalization, punctuation, and they're able to read, most of them actually get to the point where they're reading paragraphs. So people would argue to some extent that we keep pressing down in younger grade stuff they're not capable of doing. But in this case, if you present it in a proper way, all but about 3% of the kids were able to do this. And so I was pretty convinced that we did this the right way. Although, like I said, I was really concerned. And I'll tell this story later on today, too. But the principal was taking 2 school board members on a tour of the school, and they happened to come into the classroom that's using the secret codes. And they also happened to be coloring alligators, which was just absolutely brilliant for the story. Sometimes things work out way better than you think they will. And the principal said to the kids, "Oh, children, you're coloring alligators. That's really great. What does alligator begin with?" Assuming they're going to say what? Hey. And the kids go, "Ah." And the principal's like taken back by that. And they're like, "What? I have to fire this kindergarten teacher. Some craziness going on here." But one of the little kids, and granted, he was probably one of the sharper kids in the classroom, recognized facially that the principal was a little confused, and he jumped out of his chair and said, we're little detectives, we're learning the secret codes, and we're learning the secret code. He just kind of did the whole thing. And I was like, oh, I guess kindergartners get this. But they do get it, if you present it to them properly. The first grade curriculum we have is called advanced codes, and instead of looking at the phoneme, which is what they do in kindergarten, we look at the morpheme, which is the smallest unit of meaning. So we're talking about the root word, and then pre and post stuff, and what they mean. And then we also start looking at alternative spellings for things, because that's where it gets really kind of confusing, is the alternative spelling stuff.